Hi class, so this is from the Mixed Gas Law Worksheet. This should be video 10 for chapter 10 2B. We're going to go down and we are going to do number 11 together. So pull out the worksheet, turn to number 11. It says here, acetylene gas, and here's the formula, undergoes combustion. That means it's going to be burning to produce carbon dioxide and water. So how many liters of acetylene are produced? So the first thing we're going to have to do, as with all stoichiometry questions, is we have to write the balanced equation. So we have C2H2 with oxygen to burn creates carbon dioxide and water, and then we have to balance the equation. And I'm not going to worry about balancing it. I'm just going to go ahead and give you the balanced equation. 2, there's a 5, a 2, and a 4. And if you need practice balancing these equations, please see me for more practice. But we've done this a lot already. So now that we can use the balanced equation, let's answer the first question. Letter A. How many liters, so I want to know liters of C2H2, remember liters is a volume, are required to produce 75 liters of carbon dioxide. So this one's not going to be too terribly difficult. This is just going from volume to volume. Now I'm going to go ahead and write the pathway up here just so we can visualize this. So I wrote it right up here. Remember, we're dealing with molar volume, and we're going to assume that all these things are at STP. So here's where we're starting. We have 75 liters, and so this is our molecule A. So we're at volume of A. So I'm going to go ahead and write down for A. Here it goes. We have 75.0 liters of carbon dioxide, and then we're going to have to use, so we have to go to moles of A, so we have to use the molar volume. So we're going to have to turn liters into moles, so we're going to have to use this molar volume ratio. So this 1 mole is 22.4 liters. So that will be the first step, and then we're going to do the B over A to get to the new molecule. And so our new molecule is acetylene, so that's our B, and we have to do the ratio. Remember, ratios come from the coefficients, so it's the B goes on top. 2 moles of C2H2 are needed for every 4 moles of carbon dioxide, so that's the ratio. And now that gets us to this part right here, and we're going to need to go back to volume. So I'm going to use the molar volume again, 22.4 liters in every 1 mole to get us back to volume. Now let's cancel out our units, liters and liters, carbon dioxide and carbon dioxide, moles and moles, moles and moles, and that leaves us with liters of C2H2, which is what the question asks. So 75 divided by 22.4 times 2 divided by 4 times 22.4 is 37.4 liters of C2H2. And that's because we're assuming it's a molar volume. Okay? So that's letter A. And we're assuming that it's at STP. We can only do this because of STP conditions, standard temperature and pressure. That's the only time the molar volumes work. All right, what about letter B? Okay, letter B, what volume of water is produced? Okay, so now it's just basically asking me to do the same kind of thing, and we're still starting out with 75 liters of carbon dioxide, okay, but now we want to know what volume of water. Volume, that means in liters, okay? So we're going to kind of do the same thing. We start off with the 75 liters of CO2. But now we have to do the ratio between, this can become our new B, and this is still A. So we have our new B. So we have 2 moles of water over 4 moles of CO2, which is that right? What volume of water? Yeah. Okay, 4 moles of CO2. Now, that's fine, except for one problem. I skipped a step. Do you see that? And I just realized it because my unit wasn't going to cancel. I got to turn liters to moles first. So I'm going to stop and erase this and fix that error. All right, I erased it. So first thing you have to do is on the pathway. Remember, here's the pathway again. If I'm at volume, I still have to turn it into moles, and I have to use the molar volume, which is, so that's the first thing I have to do, just like we did over here. I was skipping a step. So my units weren't canceling. It was throwing me for a minute there. That's why units are so important. Now I'm going to cancel out liters, and now I know that I have just moles. And so now when I have just the moles, now I'm at the point where I can do the ratio. And now there's the B, 2 moles of water over 2 moles of C2H2. Okay, it's a 2 to 2 ratio this time. Is that right? 2 moles of water over C2H2. No, 4 moles of, I'm not doing C2H2. Golly, I'm making all kinds of, 4 moles of CO2. That's my A. Right there, CO2. I'm looking at a key and I'm looking in the wrong spots. Okay, let's erase that one again. We're going to get it right. 4 moles of CO2. See, again, it wasn't canceling. I quit looking at my key. It's sideways and I'm not reading it right. All right, so now, let's see. Cancel out CO2. Yay. Moles. Okay. And I end up with moles of water, which I need to turn into volume. And volume is 22.4 liters over 1 mole. And I can cancel that unit, moles and moles. And then I should be able to get 75 divided by 22.4 times 2 divided by 4 times 22.4 and get another answer, which should be the same as letter A. So let's double check. We'll do the math this time on the screen. We have 75 divided by 22.4 times 2 divided by 4 times 22.4, and it's 37.5, okay, liters of water. So that's the answer to B. Now you might have noticed that 22.4 here and 22.4 here, those could have canceled too. So I could have said 75 times 2 divided by 4 and gotten the same answer. So that's the answer for letter B. Now let's do letter C. What volume of oxygen is required? Okay, again, liters, volume. One more volume to volume question. All right, so we start with what we know, what we were given. That's still our A. So this is going to be a third B. Okay, so 75.0 liters of CO2. The first thing I have to do is turn it to moles because that's the only way I can go from one molecule to another. So 1 mole is 22.4 liters. I can cancel out the liters rather. And now I'm going to do the ratio from my A to my third B, my third thing they asked me about. So this is 5 moles of oxygen, O2, for every 4 moles of CO2. So now I can cancel out CO2 and CO2, moles and moles, and I have to turn my moles of oxygen into liters of oxygen. So it's 22.4 liters in every 1 mole. And then I should be able to get my final answer. And let's see, I'm going to go ahead and cancel out 22.4 here and 22.4 there, since it's a denominator and a numerator. So 75 times 5 divided by 4 will be my final answer here. 75 times 5 divided by 4. And that is 93.75. Go wait. There we go. 93.75. I have to look at sig figs. 3 sig figs at the beginning. 1, 2, 3 sig figs. 93.8 liters of oxygen is the volume. Okay, so that's question number 11. I hope I didn't confuse you too much because of the mistakes I was making. Please be careful writing in your units to keep yourself from making those same mistakes. And keep working on these